Imagine you are floating in the vastness of space, surrounded by the infinite dark void, and you come across a tiny egg. You might wonder, can this egg hatch in the microgravity of space? The answer is fascinating and reveals much about life's resilience. In recent experiments conducted aboard the International Space Station, scientists have been exploring the possibilities of life developing outside the Earth's protective atmosphere. In one such study, researchers sent fertilized chicken eggs into space to observe if they could hatch in a microgravity environment. The results were astonishing. The eggs were carefully incubated in a controlled environment, mimicking the conditions necessary for development. Surprisingly, the embryos developed normally, and some even hatched into healthy chicks. This groundbreaking experiment demonstrated that the basic biological processes required for embryonic development could occur in space. However, it was not without challenges. The lack of gravity affected the orientation and movement of the developing embryos. Scientists had to ensure that the eggs were rotated regularly to prevent the yolk from sticking to the shell, a process that occurs naturally on Earth due to gravity. One of the critical factors in the successful hatching of eggs in space is temperature control. On Earth, hens naturally regulate the temperature of their eggs, but in space, this had to be done artificially. The eggs were kept at a constant temperature of around 37.5 degrees Celsius, which is crucial for the development of the embryos. Moreover, the radiation levels in space pose a significant threat to developing embryos. The International Space Station is equipped with shielding to protect its inhabitants from harmful cosmic rays, but the eggs were still exposed to higher levels of radiation than they would be on Earth. Despite this, the embryos showed remarkable resilience, with no significant abnormalities observed in the hatched chicks. This experiment opens up exciting possibilities for the future of space exploration and colonization. If we can successfully hatch eggs in space, it means we could potentially raise livestock on other planets or in space habitats, providing fresh food sources for astronauts on long-term missions. This could be a crucial step towards sustainable living in space. Another interesting fact is that not only chicken eggs, but also other types of eggs, such as those of fish and amphibians, have been studied in space. For instance, Japanese Medica fish eggs have been successfully hatched aboard the International Space Station, providing valuable insights into vertebrate development in microgravity. Furthermore, understanding how life can develop in space can also help us search for life on other planets. If embryos can develop and hatch in the harsh conditions of space, it suggests that life might be more adaptable and widespread in the universe than we previously thought. In conclusion, the ability of eggs to hatch in space is a testament to the resilience of life. These experiments not only push the boundaries of our scientific knowledge, but also pave the way for future space exploration and the potential colonization of other planets. The next time you crack an egg for breakfast, remember that its journey from embryo to chick could potentially happen even in the vast, uncharted territories of space.